Dear customer, when we are watching this movie, you have bought or you are considering to buy some of our equipment out of our product range, technical ultrasound equipment. This movie has to be considered as a short introduction how to use the equipment. For more detailed information, please refer to the user manuals or to the test expert literature, where you can find more than 20 experiments describing this equipment. So this product range is mainly made of two equipments. First is the echograph, and the second one will be the ultrasound Doppler sonograph. The echograph has to be used with Measure Ultra Eco software and can be extended with this CT scanner unit. The ultrasound sonograph has to be used with Measure Ultra Flow software, and you will see that this one will be mainly be used for medical application and also industrial process application where flow measurements were necessary. Now we can start. I will show you how to set up the equipment. In our product range, we have 3 ultrasonic probes, a 1 MHz, a 2 MHz, and a 4 MHz probe. First, you have to connect this probe to the equipment. The echoscope will then recognize himself automatically the frequency of the probe. For the sonograph, you have to adjust the probe frequency on this knob. To pull out the probe, put it here and push away. This is a snaps lock connector. To start measuring, you have first to choose the geometry. You can work in transmission or you can work in reflection. If you will put an ultrasonic probe to a test sample, put always some coupling paste on the probe, and then you can measure in this way in the reflection mode. If we want to work in the transmission mode, put also some gel on it. Then we have to put the 2 connectors, and we have to set here on the transmission mode. Now, when the probes are connected, you can switch on the equipment. Please don't switch on the equipment before the probes are connected, because now you have high voltage on the probe connectors and it is not so good to make a hot put on. So now we have to start up the software. Before you will start up the software, you have to switch on the equipment. And then you have to start up Measure Ultra Eco software. If the software is start up, you have first to check if the connection is done. For this, choose Option and Data Transfer. Now you can see here, okay, data connection checked. So now we have a proper connection between the computer and this equipment. After starting up the software will be in this A-scan mode. So now we have to put on the probe on a sample. And now we have to choose on the equipment the transmitter power and also the receiver amplification. As you can see now here, you have some peaks which will appear. These peaks came from the surface, the second one from this floor here, and then the third peak from the bottom. In this sample here, the ultrasonic wave is also attenuated. And to compensate the attenuation in this body, you have here what is named time gain control. With this time gain control, you can increase the amplification with increasing deep. So for this, you have the first knob, which is the start point. So you can here now see the control. I have the start point. I will adjust now some slope. and also a threshold. So, threshold increase with increase, adjust the slope, and the starting position. The goal of this setting is that equal flank dimension at different depths are shown with equal heights of peaks. So for this now, we have to adjust the parameters so that the different peaks are shown with the same height. Up to now, we have worked with an amplitude representation. Other representations are also possible. So you can have a representation with the high frequency signal, where I can see the high frequency signal and also the phase of the signal, and also the high frequency and the amplitude signals superposed one to the other. Other interesting things is you can have the FFT representation of the signal. So here we have a 2 MHz probe, and we are centered on 2 MHz with the signal. Other possible settings are filter settings. This is an electronic filter applied to the input. If I will now put on filter on, then I can change the shape of this filter. Okay. Be aware with filter settings, because if your filter is not well defined, you can have strange results. But you can see filter on and filter is then in red. You have also the possibility to stop acquisition and to restart it. And you have the possibility to have a half scale and also a full scale. Then the length will be double. You have also here the depth button. In the depth button, the time scale will be transduced to a depth scale. For this, we have to calibrate the system. And how we'll calibrate the system, I will show you now. To calibrate, we need at least 2 cylinders. Better is to have 3 of different lengths. First, measure the length with a caliper. If the length is known, we will now measure at the width position. So I will take the cursor, I will put it here, and I will measure the right position of this peak. I will do the same with the 2 other cylinders. When now this position unknown, I will go and I will calculate the sound velocity and also the probe delay. So. And now we will get here the sound velocity and here the probe delay value, which you have to introduce afterwards in the A-scan window. So here we have velocity, sound velocity. And in the parameters, we can for each probe define a probe delay. So when the probe delay is set, then the calibration is done, and now we go on with the next step. Now we'll come to a typical medical application, the time motion mode. For this, we have in the software to choose TM mode. In the white part of the screen, you have the A-scan as we have seen before. So I have now to put the probe in. and I can here see my peak. I see that the maximum is about 80 microseconds. So in the software, I have to set up here 80 microseconds. Then I can start up the software. I will put the probe in it, and I have here now my time motion measurements. When I will now stop the measurement, I have here several indications to change the color view of the window. So we can change the spectra, and also to go in the black and white mode. And to make disappear this part here, or to make them, we have here a plus and a minus button to select it. So this is all what you have to know about the time motion mode, and now we can go on. The next step is now the B-scan. The B-scan is an imaging method that will say that we will create an image of this block. For this, we have to set up the B-scan screen. The B-scan screen is similar to the time motion screen. So we have again the A-scan, and here we have exactly the same windows. So we can see that we have no peak wider than 18, so we will reset as in the TM mode 80 here. We will start the measurement, and now we will slightly go on from the left to the right side of the block. And now on this image we now see the different flows herein. You can now measure the length of your displacement, introduce it here, and then the time scale will be directly translated into a wide scale. So this technique can also be now done with a mechanical scanner, which will be the next step of these demonstrations. To have a more accurate displacement with the B-scan, we will now work with a mechanical scanner. On a control unit, there are some simple commands. The first will be the speed selection. The second one will be the linear displacement. And the third one will be the rotation displacement. The rotation displacement is not used in this case because you will twist on the cable with this. So what we have first to do, we have to place the scanner in one position. So go left. And we will start up the measurement here. So on the computer now, you have to select Options, Data Transfer, and then you have to click on Check CT Scanner. Connection is done, close. Then you have here the button Use CT Scanner, and then the commands will appear here. We have first the scan length, then we have the speed, adjust, and then we have the direction. Once this is done, you can only put Start button and the measurement will start. So once the measurement is done, you can see here the image of this block, and all the other functions are similar to the function of the TM mode. So that will be the B-scan with mechanical scanners, and now we can go on to a typical medical application, the CT scanner. the CT scanner is similar to the B-scan with mechanical scanner. The only difference is that you have two probes, so you have to put here the button on transmission. As also the software works with the intensities, you have also to make the time gain control on 0. If you have done these settings, then you can go directly to the software. So select the CT scanner mode as it's done. You have then to choose the accuracy, the scan length, and the angle path you have to select, and then go to CT scan start. The software will then automatically adjust some parameters and start the measurement. At the end of the measurement, we have now 4 pictures. We have on the right side, this one, these are amplitude pictures, and on the left side are time of flight pictures. So in this block now, we have 3 tumors. The 2 one we can see in the amplitude picture, and the 3rd one we can see more better in this time of flight picture. And here on the bottom then, there you have then the filtered pictures, which is only picture treatment. So this will now be the end of the part with the use of this CT scanner and also on the echoscope. Now we will go on with the flow Doppler sonograph. This is the new PHYWE pulse Doppler Aquagraph. This equipment is used to measure flow with ultrasounds. This equipment is also computer-based, so the first thing you have to do is to start up the Measure Ultra Flow software. In this software, you have to adjust some parameters. The first parameter you have to adjust is the sound velocity in the liquid. Then you have also, as you measure on this prism, to set up the sound velocity in this acrylic. Then you have to choose between 3 angles, 15, 30, and 60 degrees. So you have 15, 30, and 60 degrees on the prism. You have also to set up the pipe diameter. You have 1/4, 3/8, and 1.5 inch tube diameter. And you have also to give up a minimal signal intensity. All parameters are now defined. Now we can start the program, the software, start up the flow, and start up measurement. To put the probe on the prism. And you can see that we have signal. For the moment we are saturating, so we need a little bit less signal. And now we have here the Doppler signal and here the flow. With the same system we can also measure the flow profile. So measure the profile, measure the flow in different heights. For this we have to put here on small. And then, with this knob, we can scan from one side of the tube to the other, passing to the center, as you can see here. So these are the main parts how to work with this Doppler ultrasound measurement equipment. So, flow measurement in medical applications. You can first find normal flow measurement and search a stenose. Or what you also can do is to simulate a pulsed flow, and then we can see how we can measure it. So first we will now measure a stenose. So first of all, we'll switch on the pump, and I will measure the flow. And now you can hear the flow, and if I will go on, you can hear that the speed will go up, and that's where we have a stenose. Now, to go on with pulse measurement, we have first to stop the pump. You have to select the mode 2, and now we will start up, and now we have a pulse flow, as you can hear and see on the screen. For this mode, you can also select in the software the 10-second section and the pulse section, so that here now you have the pulsed flow. So if I will hurry up, you can even see that this frequency will be shifted to higher frequencies, and here you have shorter pulses. So this will now finish the ultrasonic measurement of flows. You have seen that even this will be the end of this presentation. You have seen even the industrial application for engineers and also the medical application of ultrasounds. Be aware for the medical application, this is not a medical equipment, so please don't touch with it human bodies. Thanks for your attention, and I hope that we will enjoy your equipment. Bye.